Hello everyone, this is Mr. Zanoni, and today we're reviewing volume of prisms and pyramids. So, volume is the measure of space occupied by a three-dimensional region. It is measured in cubic units or units cubed. Volume is also how much a container can hold. So a water bottle's volume, how much water a water bottle can hold, how much water a water bottle can hold is its volume. Sorry, this is going to be interesting if I can't talk today. The volume of a prism is the area of the base, which we use a capital B to denote, times the height of the prism. So if I look at this triangular prism, the area of this triangle is the base, capital B. The height is how far is it from one base on a prism to the other base. So how far away are these two triangles? How far is this point to its matching point on the triangle? How far away they are, that is the height. This measurement here is the height. Okay? Because this area is the amount of space the water could take up, and this is the depth that I could take this triangle and push it back to this one. How much space could I fill in this entire thing with is the height. How far could I... This is the areas, the amount of space the water could take up. In this one ring, the height would be how many triangular rings it could fill. Okay? So, the volume formula for a cube, it's really easy. Just take the side length and raise it to the third power, because a cube is made up of 6 squares, so 10 by 10 by 10. Okay? Alright. And then with a rectangular prism, it's a little trickier to figure out, because you can pick not one, not two, but 3 different bases depending on what you want. It's not really going to end up mattering. Just your math looks different. You'll still get to the same answer. So we're going to move on. It's just easier to see with a triangular prism. Okay. So example number 1. Find the volume of the rectangular prism on the right-hand side. Well, volume equals base times height. I'm choosing this rectangle on the bottom to be the base. What are the dimensions of the rectangle on the bottom? 4.2 times 3. So 4.2 times 3. And then I would multiply by the height, which is 5. How far is this base to its congruent parallel base, which is up here? Okay, this would be the height, which is 5. And that's how I set it up. I use a calculator to multiply. 4.2 times 3 is 12.6. Times 5 is 63. So the volume is 63 centimeters cubed, or cubic centimeters. Again, we're going to find the volume of the triangular prism in this one. So the difference between a rectangular prism and the triangular prism are 2 things. One, the area formula for a triangle, you do base times height, but then you divide by 2. You didn't have to do that there. Also, the dimensions are a little different. You are forced to use 2 and 6 for the base, because those are the corresponding lengths on the triangle, the base of the triangle and the height of the triangle. So I'm going to substitute in for volume equals base times height. The area formula for capital B of a triangle is 1/2 the base of the triangle, which is 6, times the height of the triangle, which is 2. So I have 1/2 times 6 times 2 times the height of the prism, which is 7. So this h represents the height of the prism. These two h's are not the same value. That can be kind of confusing for some people. I'm just quickly reminding you that they're different. They mean different things. Okay? The volume, and then when I plug that in, 1/2 times 6 is 3, 3 times 2 is 6, 6 times 7 is 42. So the volume of the triangular prism is 42 cubic centimeters, because we did centimeters times centimeters times centimeters. That's why it's cubic centimeters. Okay, now let's talk about the volume of a pyramid. Is the area of the base times the height of the prism times 1/3. So pyramids are weird. If I'm going to mess with the picture of the cube up top here. So if I was talking about a square pyramid, I'm going to say it's upside down. Let's say this is the base of the pyramid, and then it comes up to the vertex. Okay? How many triangles do you see on my cube here? You see 1, 2, 3. A pyramid compared to a prism of the same variety, the pyramid can only hold 1/3 of what the prism can hold. So that's where this 1/3 in the formula comes from. The area of the base times the height. The only difference between a prism and a pyramid is you multiply this by 1/3, or you could say you take this and then divide it by 3. Okay? So, if we look at the triangular pyramid here, the base of the triangular pyramid, so what I'm going to do is I'm going to write the formula for my volume of pyramid. V equals 1/3 base times height. I'm going to substitute area of the base in with the formula for a triangle, which is 1/2 the base times the height. These are just side lengths, that's why they're lowercase, versus the uppercase letter, which stands for area. Now I'm going to substitute in the values, or replace them. So the base of the triangle is 8. The height of the triangle is 6. The height of the pyramid is how far is this base from the vertex of the pyramid, which is 5. And with a pyramid, the height of the pyramid goes from the vertex down to the base, and it's in the inside, typically, on a pyramid. So 1/3 times 1/2 times 6 times 8 is 1/3 times 24 times 5. 1/3 times 24 is 8. 8 times 5 is 40 centimeters cubed. So the volume of the pyramid is 40 cubic centimeters. All right. Now, the next one is a composite solid is made up of 2 or more solids: prism, pyramid, cones, etc. So we talked about an area of composite figures. We talked about how to find the area of things that looked like this, right? I'd find the area of this shape and add the area of this shape. Well, it's the same idea here, except for we're now dealing with 3D objects and we're dealing with volume. So finding the volume of the composite solid, I would find the volume of the rectangular prism and add the volume of the triangular prism. Now technically there is one more way I could solve this problem, but for our purposes I want to show you how to break this down into a composite solid, because you need to know how to do that, because we don't always have nice 3D figures to work with in life. So volume of the triangular prism plus volume of the rectangular prism. So area of the base times the height. Substitute it in the formula for a triangle's area, which is 1/2 base times height of the prism. Substitute in area of the base of a rectangle, which is base times height times height. Now I'm going to start plugging things in. The base of the triangle is 10. The height of the triangle, which makes a 90-degree angle here, is 2. And how far is the triangle in the front from the one in the back? You actually get from this measurement over here, which is 3. Okay, you can probably see this more clearly on your paper. So that's where the 3 came from. Now, if I'm looking at the rectangular prism, the base of the rectangle is 6, the height is 2, and the height of the prism, how far is the front rectangle from the back one, is this measurement again, which is 3. Now I'm just going to go through and multiply. 1/2 times 10 is 5, 2 times 3 is 6, 6 times 2 is 12, okay? 5 times 6 is 30, 12 times 3 is 36, 30 plus 36 is 66 feet. The volume of the composite solid is 66 cubic feet. There's one more example I want to go through with you, okay? You are designing an air conditioner, which is a rectangular prism with a volume of 1600 cubic inches. If the base of the air conditioner is 16 inches and the distance from the front to the back of the air conditioner is 8 inches, what is the height of the air conditioner? Okay, so if I draw a rectangular prism to help me solve this problem, I know that this is 16, and I know from the front to the back is 8. I don't know what this measurement is. That is what I'm solving for. Okay, so let's set it up. Volume equals area of the base times height. Volume equals, we'll substitute the area formula in for base times height of the base, height of the base times height of the prism. Then I'll substitute in the values I know. I know the volume is 1600. I know the base is 16. I don't know the height of the base. That's what I'm looking for. And I know the height of the prism is 8. Then I'm going to multiply what I can over here. 16 times 8 is 128. Now I have 1600 equals 128x, sorry, 128h, excuse me. And since I know this is a one-step equation, I'm going to solve it by undoing PEMDAS. I'll divide both sides by 128 and get h equals 12.5 feet. So the height of the front of the air conditioner is 12.5. Why does it say feet? Oh, it should have been inches there. 12.5 inches, excuse me. Okay, now we're going to go through and we're going to solve the following problems. I'm going to have you solve the following problem and puzzle, and then continue watching me solve them, okay? So, here we go. Volume equals area of the base times the height. I substitute in the volume formula for a triangle. 1/2 base times height times height. Okay? Volume equals 1/2. The base of the triangle is 6.5. The height of the triangle is 8. And then the height of the prism, how far is the triangle from the front, from the one in the back, is 15. Now I'm going to start plugging some things into a calculator. Okay? Just getting my calculator handy. I apologize. So, 6.5. So this is 3.25 times, I'll multiply the 8 and the 15, it doesn't matter right now. 120. And then the volume will equal 390 inches cubed. That's my volume that you should get there for the triangular prism. Now let's do the rectangular prism. I'm going to pick the rectangle that's on the bottom as the base. It doesn't matter which one you pick here. You'll still get the same answer. So I still start with my volume formula. Area of the base times the height. I'll substitute in the rectangle area formula here. So the base is 20.5 because I already chose it. 6 is the height of the base. And the height of the prism, how far is the rectangle on the bottom to the other congruent parallel base? The height of the prism is 8. Okay, and then in my calculator, I'm going to do 20.5 times 6. I have 123 times 8. So I know the volume equals 123 times 8. So I get 984 cubic millimeters. Okay, that's my volume. Move on to a cube. This one we can just use this formula, the side length cubed to the third power. So volume equals 8 to the third power. In the calculator, I'm going to do 8. There's a little caret button I could use. And I would get the volume equals 512 cubic centimeters. Or centimeters cubed. Or in the calculator, you just do 8 times 8 times 8 if you don't know how to do 8 to the third power, but you should. And then I have a pyramid here. So my volume formula is 1/3 area of the base times the height. Again, I'm going to do some substitution. 1/3. We're going to substitute in the formula for a rectangle, which is base of the rectangle times height of the rectangle times height of the prism. Okay, now let's fill this in. 1/3. The base of the rectangle is 12.2. The height of the rectangle is 4. The height of the pyramid is 15.1. Again, you notice it makes a 90-degree angle and it's inside the pyramid up to the vertex. Okay, and now we're going to start doing some multiplication. I'm going to wait to multiply by this 1/3 last because it's a repeating decimal, and quite frankly, would like to deal with rounding last. So I'm going to first multiply 12.2 times 4. So volume equals 1/3, 48.8 times 15.1. Again, I'm going to multiply these first and then deal with the 1/3 last. Just because it's otherwise going to create some sort of nasty number, probably. 736.88 when I multiply these two together. Now I will multiply by 1/3. Yeah, and I'm going to end up getting 245.626 repeating. In my directions, I said round to the nearest tenth. So if I round to the nearest tenth, I get the volume is this. If I said nearest hundredth, it'd be 0.63, but it's not hundredth in this case. Okay. Alright, we got a couple more problems to do. So, okay. We need to find the volume of each figure below. Okay, this is pyramid. 1/3 times the area of the base times the height is the formula. Always write down the formula, and then I'm going to show that I'm plugging in substitution for each one of these. Okay, 1/3. Plugging in the area formula for a triangle. 1/2 base of the triangle times height of the triangle. 1/3 times 1/2 times base of the triangle is 12. Height of the triangle is 12. And height of the prism is 17. 1/3 times 1/2 is 1/6. 12 times 12 is 144 times 17. I know I can divide 144 by 6. I can do this and it'll be a nice number, so I'll take care of it now. If I didn't know that, I would wait for to multiply by 1/6 in the end, but since I know I can do it, and then I'm just going to multiply this by the height of the prism to get 408 inches cubed is the volume. Sorry. Okay, find the volume of the composite solid. Okay, so volume equals volume of the triangular prism as volume of the rectangular prism plus volume of the triangular prism, okay? There is another way I could solve this with just calculating the volume of a trapezoidal prism, but I want to show you how to do this with to find the volume of a composite solid, okay? So, base times height plus area of the base times height plus area of the base times height of the prism, then 1/2 base of triangle times height of triangle times height of prism plus base of rectangle times height of rectangle times height of prism plus 1/2 base of triangle times height of triangle times height of prism. Okay. 1/2 base of the triangle is 3. Height of the triangle is 3. Height of the prism, how far is this triangle in the front here? To how far is it in the back? That would be this dimension here, which is represented by 7. Rectangle base is 5. Okay. Height is 3. And then height of the prism 7. Because a property of rectangle is this length and this length have to be the same. And then this length and this length would have to be the same on the rectangle. So that's how I know this is 5. Okay. 1/2 the base of 1/2 the base of the triangle. Again, it's actually going to be the same thing that we did over here, because these happen to be the same size, which is nice. So then I have 1/2 times 9 times 7 plus 15 times 7 plus 1/2 times 9 times 7. So I get 63 over 2 plus 15 times 7 is 105 plus 63 over 2, which if I combine these, I get 105 plus 63. So I get the volume is 168 centimeters cubed. Okay? And I'd probably write that in a sentence. Okay? Now the last one is a children's rectangular pool holds 17.5 cubic feet of water. What is the width of the pool if its length is 3.5 feet and its height is 1 foot? So, what I'm going to do is I'm going to write my volume formula. Volume equals area of the base times height. I know it's a rectangular pool, which means it's a rectangular prism. So I'm going to then substitute in 17.5. I'm going to put in my area formula for a rectangle. Okay? The width of the pool. I'm looking for the height. I should have... The height of the pool, I'm sorry. Anyway, 17.5 equals... I'm going to use 3.5 for the base. I don't know what the height of the rectangle is, but I know the height of the prism is 1 foot. So then 17.5 equals 3.5h. It's a one-step equation, so divide by 3.5 on both sides to get our answer. And you're going to get the height, sorry, not the height, the width, 17.5 divided by 3.5 is 5. You're going to get the width of the pool is 5 feet. Okay? And that's it for reviewing volume of prisms and pyramids. Thank you for watching.